Hello, welcome to our lesson for today on further mathematics. We'll be discussing on the topic projectiles. But before we continue, I would like us to take a quick review of our last lesson. Okay, thank you and welcome back. Now, have you ever wondered what happens when let me say this is a young boy, when a young boy or a young man this is now goes into projecting a rope from this point to a given point. Now look at what happens. If this happens to be a bird that dwells in the tree, now I want to explain a concept. Now this is a tree with a human singing bird on it. Let me now say this is a projection of a young man trying to shoot down a bird from a tree. Now there's something that happens at this point. When you talk of projection and projectile, you're talking about the process of trying to subject an object above a level, trying to target a horizontal object, but calculating it in a way that at the end of it, it will fall back to that point which you're targeting. Now, when you talk about projectile, there are things we usually take into consideration. Number one, we talk about the horizontal distance. We talk about the horizontal distance. We talk about the projected distance, which happens to be the range. We talk about the angle, let me say theta, which happens to be the angle of projection. We also take into consideration, okay, this is the angle of projection. We usually identify it as theta. It serves as the angle of projection. Then we also talk about the maximum height. The maximum height is this height. At the point where you have the highest point, you know, from here, this is a level ground, a level point on the air. Projected object travels through this point. It gets to a maximum point that it will start falling down. Now we'll have to calculate the maximum height. Have to get the maximum height, the range, the horizontal distance, and now what is the speed of the stone? I've been the stone projected. That is, it is called the initial velocity. An initial velocity helps to tell us the speed of the stone. It tells us how the stone, or what is being projected, how it travels from this point to this point. So next time you want to perform a motion that has to do with projectile, there are certain things that we need to count, just like what I've listed here: 1, 2, 3, 4, 5. These are the 5 key things that we really need. I will always consider the acceleration due to gravity. To be approximately 10 or 9.8 meters per second square. Now these points are very important for us to note when we want to deal with projectile, of how a projected object travels from one point to another, and these are the basic parameters that we need to take into consideration whenever we are dealing with projectile. Now the first part I want us to talk about is stating the equation of the parameters we just mentioned. Like it's talking about the time of flight. I told you that the time of flight means the total time required. The time of flight is the time taken for the object being projected from where it is being projected. You know, we are talking about time of flight. So the time it took the object to move from its position to the end point, and it's being calculated as 2u g. Remember, this is the nature of our projected motion. It goes this way. So the time it took from this point to this point is called the time of flight, and it's calculated as 2u sine theta and it's calculated as 2u sine theta all over g. That's the equation for time of flight. But if the time taken for this object to travel from here to here is this, so that is to say time to get to the maximum height. Time to get to the maximum height, if here to here is 2u sine theta over g, so time from here to here will now be u sine theta over g. You take off the 2. That is it for time of flight. Then another point I want us to take into consideration is the maximum height. In order for us to get the maximum height, we make use of the equation u square sine 2 theta over what? 2g. That's for maximum height. Then if you want to calculate the range, that's the distance traveled by the projected object, is u square sine 2 theta all over g. That is for the range. I think these are the major parameters that we really need to explain how to get it. And from this diagram, let me put it this way, from this diagram, the angle of projection is here, theta 30 degrees. The speed at which this object used in leaving the projected point is called u. That is the initial velocity. That's the initial velocity of the object. Now let's move further into performing some calculations. Now I would like us to go into this. Question 1. An object of mass, an object or a particle, an object was projected with an initial velocity of 56 meters per second and its angle of projection was 60 degrees. Calculate the maximum height reached and the time taken to get there. Time taken to reach the maximum height. Now I said the formula for maximum height is equal to u square sine squared theta all over 2g, which is equal to our u square here is, remember our value of u is what, which is 56 square sine 60 all squared divided by 2 times 9.8, because the value of our g is equal to 9.8 meters per second squared. That's acceleration due to gravity. So from here we have theta to be equal to 60 and u equals to 56. So this and this will give us 120 meters. That is the maximum height. Then the second part of it says the time taken to reach maximum height. I said the time taken to reach maximum height is sine theta, u sine theta over g, which is equal to our value of u here is 56 times sine 60 over 9.8, which is equal to 4.9 seconds, which is equal to 4.9 seconds. So I'll say a very big thank you for joining us in today's lesson. So I want you to take the test that will be appearing very shortly right in front of you.